Hey everyone, welcome back to another video. So this is probably the most requested video I've had since uploading the other ones, and that is my Oculus Quest 2 settings and what I use to get it on the headset. Seems like a lot of people have been having issues with this, but there's some things that we can cover, and we're going to do that at the beginning by just going through the key things first, and then we'll take a look at some other things we can do. So before we get started, I want to say thank you to all the Patreons. They actually voted on this video to be next. So if you want input on that, make sure to head over there, and you can do some votes, which would be pretty cool. And basically everything helps try and do this full time from now on, which will be absolutely wicked. So the first thing we're going to do is we're going to load up our virtual reality template. And the reason I'm using this is because some people have had issues with it. So the idea is to cover this and go through it. So we've got no starter content. I've got a folder that I'm already in there. And here we do not want to name it test. So a lot of people have issues building their project because they name it test, and then that causes conflicts down the line. So whatever you do not do it. Make sure it's something project or project along that line. So this one, we're going to call this Quest Test Project. So we can hit enter, and then we can actually go create project. Another thing you want to keep an eye out is make sure there is no symbols or spaces in your file names. That includes the entire file name list. So if we go show explorer, you can see here the entire top part is there's no spaces. I also forgot a T from the test, but not to worry. So make sure there's no spaces along here, otherwise that can cause issues as well. It's quite a pain, but as long as you get into the habit of not using spaces or symbols, you work quite well towards it. So the first thing we're going to do is actually open up our project settings. So rather than covering every setting, we're going to cover the key ones first, and that is actually our Android settings. So if you follow the last video, you'll have Android Studio installed and set up. Mine's set up for Android 29, I believe, and that's the first thing we're going to do here. So I'm going to go to my Android, I'm going to hit configure, and I'm going to make sure my SDK and target SDK is 29. This might be different for you based on what you've got installed or what is actually shown on the Oculus website, but for now I'm just going to use 29 because I know it works. So in here, we want package game data inside APK to be true. Allow large OBB files. That allows up to 4 gigabytes for projects. This build should only be about 150 megabytes or less, hopefully. So we shouldn't actually have to worry about that. We then want to scroll down, and this is probably the key section that people get caught up on. So a lot of people keep using OpenGL, or if you actually use OpenGL, it causes your load to just continuously your application to continuously load. You can hear the background audio from the fire that's in the scene, but building it just causes a load screen up here. So we're actually going to disable OpenGL, and we're going to set our support ARM to 64. So Oculus documentation actually states that if you want to push to the store, you do need to use ARM64. So we're going to take that and make sure ARM v7 is disabled. That is it for here. But the last thing we want to do is actually make sure remove Oculus signature files from distribution APK is set to true. If we do this, it actually removes a file that stops a check. So rather than just having a black screen load up, it would actually load our project. So if I haven't got anything from the basics, if I do a quick little glimpse before we actually have a look at the rendering tab in a minute, we should actually be good to go. So what we're going to do is we're going to go to VR template, File, Package Project, Android, and ASTC. The reason we're using ASTC, or the reason we're building through the package project, is it's more accurate. People have been using the launch tool, so you can launch it up, and when you do that, it loads on the headset and it works fine, but as soon as you go to package the project, it fails. So you don't know if there's actually any issues in it. So always when you load your project and you're about to start something, make sure you build from File, Package Project, Android, ASTC. This will save you so much pain down the line if you know your project builds from the start. So we're going to do Android ASTC, and we're going to create a new folder in here, and I'm just going to call it APK. So while this is building in the background, I'm going to go over a couple of issues that might be causing your build to fail, as people have been having issues in the Discord. So if you do have issues, make sure to head over to the Discord. We'll try and help you if we can. But just remember, we're doing this for fun. We've kind of got the server going, and we're just trying to help each other out. So if we're not in there from the start, just hold on. Someone will be there. Someone will help out. So with that done, one of the issues that you can cause is you might actually get a build fail, something to do with Visual Studio. You might not know about it, but it might just error out. So one of the things you can do to test this is actually install Visual Studio. And if you do that, make sure in Visual Studio So if we open it up, so I'm using Visual Studio 2022. I'm going to do continue without code because we want to take a look at the tools and get tools and features. That's if I've opened the right one. Yes, so we're in the right one. So if you install Visual Studio to try and get the build working, what you want to do is you want to make sure you go down and find game development with C++. You want to tick that. And before building the whole thing, you want to make sure that the individual components are all done. And the key one here, there. So this is what it would look like. And we don't need the Unreal installer or anything like that. But if you're using this to test and try to figure out your build, make sure you have MS build ticked. That's the key one. So game development C++ tick, and then MS build. If you can't find it there, you can go to individual components, and you can search MS build, and you can see it here at the bottom. So if your build failed and you don't know why, and you have Android Studio set up, then install Visual Studio and give that a check as well. So leave this to do its thing. So we're going to close this. And once you've installed Visual Studio, if you're used to using something else, you'll want to go to Edit, Editor Preferences, and then in here, you will want to go to Source Code and set Source Code Editor to the version that you have. So I know some people use Visual Studio Code, so you'd want to change it to that if you do it that way. So I believe our project has built. So if we look at our output log, it says build successful down here in the bottom left. So that means our APK is good to go. So we've covered project names, we've covered the Visual Studio. There is an issue, or there is an error called something Java lang out of memory, I believe it is, which means that your application is bigger than 4 gigabytes in size. The application itself might not seem like it, but it creates an OBB file, and if that is bigger than the 4 gigabytes or the size of your application, it will fill the build as well. So make sure your project's below that. If you're using the template, you should be fine. So it becomes an issue later on down the line. But what we can do now is actually open up our APK file. And I'm going to do that by just selecting one of these folders, going back to my file where I saved it. And then I'm just going to double click install the application. As long as I make sure my headset is connected to the PC, which it is, and make sure when you plug the headset in, you accept desktop permissions, so you allow it to communicate with the PC. That way, once this is done, it'll automatically build it, and then it'll do that, so it'll close itself. Awesome. So what I'm going to do is I'm going to minimize this. And before we boot the application up on the headset, I'm actually going to use side quests so you can see my stats. So I'm actually using the Oculus Developer Hub. And in here, in Device Manager, I've actually enabled my metrics HUD. So this will install OVR metrics, which is a monitoring tool that you can display inside the headset. If I was to screencast it to the PC, you wouldn't be able to see that, which is why I'm using SideQuest just to show it to you. So we're going to open up SideQuest, hit the stream button on the top, Quest 2, and then it's not the best picture in the world, but it should still help you get an idea of what we're looking at. So now we've got the headset on, we can actually see through OVR metrics our performance and headset stuff. So I had a window open in the background and it's been a little bit funky, so that's why the performance is so down. But we can see these stats updating live as we use the headset. So what we're going to do is we're going to open our unknown sources here in our apps and then top right to the bottom. And then we can go to Quest Test Project. So with that done, we're now loaded up into our project and we can actually have a walk around, move around. When you first teleport, the performance will dip. It's just when it's setting up the inputs and stuff like that. But as you can see, we can still access everything and we can see everything in the scene. So that's exactly what we want. So what we're going to do now is take a look at some settings that we can use to reduce the CPU and the GPU level, especially from getting the GPU level down to 2 and 3 with a stable frame rate instead. So let's quit out of this. And it's important to note that there is a performance hit when using the screen capture. So there is that to consider as well. But what we're going to do is we're going to open up our project again, and then we're going to go through some project settings that we can actually reduce in rendering. So there's some information in here that is pretty much good to use, but everything from now is kind of use as your own preference. Stuff we've changed to get the stuff on the headset is absolutely fine, but we can do a couple of other things to try and bring the performance head down and reduce file sizes. So before jumping to rendering, I forgot we need to go to packaging, and in here we're looking for this drop down that says show advanced. So right here, and we're going to change some stuff in this. So at the minute, our project is building any maps that might exist. So what we want to do is we want to do cook only maps. And when we take this, we need to set which maps we load into the headset. So we can do list of maps to include and package build. We're going to hit the plus. And then we're going to select our actual map from VR template, maps, VR template map. So now when our application builds, it will only build the application that we're specifying, or the level that we include. If you're doing level streaming or anything like that, you'll have a persistent level and then you've got sub-levels. Make sure you include all of those in these as a list. So once we actually have a look at it, it should be good to go. So we can keep an eye on this. So it's at 137 megabytes so far. It's our original build. So that's all good. Then we've got exclude editor content when cooking. So this is a fiddly one because if you enable this, it removes about 2 or 3 megabytes worth of content from what I've seen. But the issue is as well, the cubes within our level, or these ones specifically, have content in the exact folder we're telling not to build. So exclude editor content when cooking. It says, don't include content in the editor folders when cooking. This can cause issues with missing content in cooked games if the content is being used. And in this case, our cubes actually have materials on the static mesh, which can be found inside of our VR editor, our engine content VR editor base meshes. So this actually stops these from being built. So if you're not using those, you could actually go ahead and exclude editor content. I'm going to keep it on because I like the cubes. I'm going to be using them. Now, once we've done that, we can do exclude movie files when staging. If you're not using videos, you don't have to worry about it. If you are using videos, I highly recommend doing this and then specifying which movies to package. For example, I'm working on a project right now and it's got about 20 movies in the project, but when I build it, I only need a handful of them. So it's actually going over the 2 gig limit and then it's causing issues building to the headset, which is where that Java Lang memory issue came into place. So once we've done that, we've got everything else sorted. And one thing to point out is blueprints and blueprint nativization method. So what this does is it converts blueprints into C++ code, which can help your performance, especially on the headset. And people have seen, or the discussion is really that you see a performance when doing math in blueprints. So math in blueprints is quite heavy. So nativizing or converting a blueprint in your project into C++ code can be faster. But be careful because this can cause some errors as well. So you want to be careful what you do. You can do inclusive, which will build all blueprints to C++, or you can do exclusive and use the drop down to actually select which list of blueprints or which blueprints you want to use and convert to C++. So for now, I'm going to leave this to disabled and we can actually move on to our rendering. So in rendering, if we scroll to the top, we have our mobile MSAA currently set to 4. Don't change this, don't move it to 8. 4 is perfectly fine and it looks fantastic. So there's no reason to change this. People have been doing it and getting issues. So just keep that in mind. And I'm actually going to enable software occlusion culling. So whether to support software occlusion culling on mobile platforms, this will package occluder information and enable software occlusion culling. So if you do this, you want to tick it. But just as a heads up, occluder information isn't stored on geometry by default. You have to actually open up the mesh. So if we select one of these cubes, because they all use the same 1 meter cube, we can double click this. And then if we open it up, we can change our drop down in our general settings, I believe. LOD for occlusion, occluder mesh. At the minute, this has LOD autos and it's only got the 1. So what we want to do is change this to 0. So 0 will use the default mesh. If you are using LODs, choose one of those instead because it's less information that the GPU has to remember as well. But I'll do a video on LODs and everything else in a future one. So make sure you like and subscribe so you don't miss that one. So it's safe. We can go back to project settings. And for some reason, every time I close it, it moves rendering. And in here, we've got a couple of other options. So we've got mobile ambient occlusion. So it says caution, an extra sampler will be occupied in mobile base pass pixel shader after enable the mobile ambient occlusion. Changing the settings requires restarting the editor. So we're going to do that. I don't really use it because I don't really see a difference in it, but I think some people probably will just to try and get that quality out of it. Also to note, which I should have probably said earlier on, we will not be using mobile HDR, so there will be no bloom and there will be no post-process effects because they're not supported on the Oculus Quest 2. If you want to see bloom, I will have a video coming shortly, depending on how patrons vote for it, on how to fake bloom to a point that is good for performance and you can get a decent result out of it as well. So make sure to vote on that if you can. And now we've got supports desktop. We don't need to do this. So game materials. So game discards unused material quality levels. This is really good because it can save us some memory. So discard unused quality levels when loading content for the game, saving some memory, basically what it says on that last line. So what we're going to do is we're going to check this because our project only needs ASTC, I believe. So we can actually tell it to ignore it, which we'll do in a bit. So we're going to do game discards unused material quality levels. And then if we keep scrolling through, we're going to get to reflections. So reflections capture resolution. I changed this to 64, basically half of the default, because on the Quest, reflections aren't great. Don't try to push them. Work within the limitations of the device because it is not a desktop graphics card. It's a mobile, which people seem to forget. So make sure you remember that. And then mobile reflection capture compression, we're going to set to true. Forward shading set for us, so we don't have to worry about that. And this is another setting that I often change because I don't use decals. Decals haven't worked on Quest for a while, I believe. I haven't used them anyway, so they're quite performance heavy due to the transparency in them. So debuffer decals, I actually disable these or this, but it will require shaders to compile, so it could take some time. But it generally says whether to accumulate decal properties to a buffer before the base pass. Debuffer decals correctly affect light map and sky lighting, unlike regular deferred decals. Debuffer enables forces a full pre-pass. Changing this setting requires a restart. So basically it uses directional lights to update decal information. So we don't need that. Then if we keep going, this is an area where people have a habit of changing. Touch it. You generally don't need to. As we've seen, it builds to the headset and it works. If you enable mobile HDR, something's gonna break and it's gonna be crap because you're gonna take this just to try and get bloom. And the key thing is to remember it's a mobile. I keep having to say this in the Discord and go over it as well. It's not a desktop graphics card. It is a mobile phone and there is restrictions to it. You can't push all the information you need to the device. So make sure mobile HDR is off. It's not worth it. So with that little rant over, we want to go to HMD, fixed foveated level experimental. I normally set this to low. You can keep it disabled if you want, but it gives us some more performance. And then custom depth stencil pass. So this one is used for things like edge outlines on characters. If you're doing a cell shader style, we're using post-process effects. If you're not, don't worry about this. You could just disable it. I've never had any issue by disabling this, but no doubt somebody will leave a comment in the description about the settings I'm using. So make sure to keep an eye on that as well. So now we get to default settings. I actually leave everything as it is. Apart from on occasion, I change the auto exposure bias. I typically put that to 2 just to make the scene brighter. So we're going to do that now. And if you do this, you want to make sure you select your VR pawn. So VR template, blueprints, VR pawn, and we actually want to select our camera. And the reason we're doing this is because the camera has its own post-process attached to it. And we can disable this by setting our post-process blend weight to 0. So when we do that, we just compile and save. Then we can close these and we can go back to our rendering tab. So we scroll down, we've got this set to 2. So this will override that camera anyway, but it'll just do the brightness. Then we've got anti-aliasing method MSAA. You don't want to change this, keep it as MSAA. Never had an issue with it and it looks great. Plus it works better on mobile. So now we can do the show advanced and frame buffer pixel format. I actually changed this to 8-bit. There's no reason to have the 2-bit alpha or the 10-bit, especially when working on the Oculus. So now we get down to optimizations. And what we're going to do here is we're going to uncheck render unbuilt preview shadows in game. So it says here, whether to render unbuilt preview shadows in game. When enabled and lighting is not built, expensive preview shadows will be rendered in game. When disabled, lighting in game and editor won't match, which can appear to be a bug. I do this because it reminds me when I put the headset on that I need to build my lighting and that there's issues there, because you should always build your lighting with the Quest. You should always use built lighting basically. So we're going to disable this one. And what we need to do now we've done that is actually build our lighting, because you can see here, now we go back to our scene, it says lighting needs to be rebuilt. And before we do that, we're going to make sure our lights are stationary. So at the minute, our skylight is set to static, which is exactly what we want. But our directional light is set to stationary. We're just going to set this to static, and then we're just going to hit build. So this should only take a second or two, depending on how your PC is. But now we've got that, we've updated our shadows, and we can go back to our project settings again. So rendering, early Z-Pass, I actually leave this on decide automatically. I never usually change it. On some occasions I have done none. Let's leave it for that for now. And then everything else in here, if I remember correctly, should be fine. If you're using the old particle system, you might want to use enable particle cutouts by default. Because you can see here, when enabled, after changing the material on a required particle module, a particle cutout texture will be chosen automatically from the opacity mask texture, if it exists. If not, the opacity texture will be used if it exists. So it can actually save a couple of, I don't know, milliseconds or whatever. So somebody will correct me on that. But we're going to do enable particle cutouts. And then you can actually go as far as disabling support depth only index buffers and support reversed index buffers. So you can see here, support depth only index buffers, which provide a minor rendering speedup at the expense of using twice the index buffer memory. So it depends if we want the rendering speedup compared to the buffer memory. So I'm going to let you guys decide which one you want to do on that. It's worth playing around, but I think actually for now I might just leave it as it is. So those both on true. So if we keep going down, permutation reduction, and I'm actually going to disable sky atmosphere because it doesn't work on mobile. Atmospheric fog because it doesn't work on mobile. And we could do some of the others, but I'm actually going to leave them as they are. And now mobile shader permutation reduction is what we are actually after. So use shared movable spotlight / point light shaders. I'm going to disable. Max movable spotlights / point lights. I'm actually going to set this to 0 because on the Quest you really shouldn't have any movable lights. If you do, it's going to impact performance. So use that as your best judgment and then go from there to decide what you want to do. Support movable directional lights. We've set ours to static, so we don't have to worry about it. And then we'll leave the other two as they are because we don't really use them anyway. So that is it for our rendering. Now what we can do is we can go down to our platforms and then we can change our Android material qualities. And what we're going to do here is we're going to do discard quality during cook. And we're going to set this for low, medium, and epic because we're using high. So in here, we're going to do a bunch of stuff. And we're actually going to tick all of these. So force fully rough, force non-metal, disable light map directionality, force low quality reflections, force not use pre-integrated, GF for simple IBL. Not, to be honest, not actually sure what that is. Disable material normal calculations. And then I leave mobile shader shadow mapping quality as it is. So just go through and we tick all of those. Is good. Yep. And then we're going to do the exact same thing for material quality level Vulkan. So low, medium, and epic discard. And then we tick all of these as well. And then we do the same thing for Android SM5 material quality Vulkan. Rinse and repeat. And then we're actually all good to go. If you're using the settings in here for preview rendering Android Vulkan, which is what we put it set to, you could then update preview shadows, shaders, and it'll actually update in your scene. But it will compile shaders again, so be careful. But what we can do now is actually restart our project, and then once that's done, we can do another build. This might take a while because it is compiling shaders from scratch. So we're going to do restart now, save selected, and once this is done and all the shaders will be built, I'll be right back. Okay, so I was actually wrong. It didn't compile any shaders because in rendering, I didn't do deferred decal, I believe. So this is editor preferences, project settings, rendering. I'm just going to double check just to make sure. I disabled it. So not too sure why I didn't compile shaders, but that's all right. What we can do is we can go to File, Package Project, Android, and then ASTC. If you remember, I said that actually. So another thing that might be causing an error, which I forgot to mention about, is your intermediate file. If you go to project settings now and you build this project, there's a small possibility it might not work. So what we're going to do is we're going to go to Content, just open this up so we can show in folder, so we can see our project files again. And I'm going to close our project. So now we've updated our project settings. We're going to select all the files in here that we don't need. And they are the binaries, build, derived data cache, intermediate, which is the important one, saved and script. I don't have anything in script, so I don't have to worry about that. If you're using Vive Focus 3 or something like that, you might actually have a plugins file in here, or if you're using plugins, don't delete the plugins, it's not worth it. Just keep the plugins folder, config, content, and the U project. Once you've got that, you can actually just select all of those. We can delete it. So it's saying that we've got something that's there, so we're just going to skip it, which not too sure what happened there, but it worked. So we're going to double click our Quest test project because I forgot the T. That would have actually been a really good time to rename it, but now it's loaded. We'll actually go to File, Package Project, Android, ASTC. We'll select our folder. So now all we're going to do is wait for that to build. And while that builds, I just want to say another thank you to all my patrons. Like, you guys are absolutely awesome for helping me be able to do this. And hopefully we can get more content out this next year and do some awesome stuff. We've got some big plans. Just got to try and get it all sorted. And with you guys' help, I'll actually be able to do that. So be absolutely awesome. So make sure you head on over there if you want to. Or if you can't really help out on the Patreon, make sure to head over to the Discord. even just being there helps quite a bit. So make sure to do that. Actually helps everyone. Be awesome. Excellent. So our build succeeded. If we go to edit, or we go to window, developer tools, and then output log, we can see at the bottom here it says build successful. So what we can do is we can actually open up that APK file, make sure I've got the right one. So it is 9:17, 2 minutes. So now we can actually just double click this and go for it. And if we remember correctly, I think we've lost about 10 megabytes, which is pretty good. So we just do double click install. We then wait patiently for that to finish as well. And after this, we can literally put on the headset and we should be able to jump right back in once it's finished as it has. So let's go to side quest, start a stream, and then in here to our apps, unknown, Quest test project, and then we can boot this up and we can see our project has loaded up. Our CPU is now on level 2 and our GPU level is also on level 2. FPS is currently at 72 because I've got my headset set to that by default. Now we've got our controllers in here, we've got our guns, got everything spawning in, and the only down drop that we see in our performance is because it picked up the movements and the inputs. We've got audio as well. Pick up these and we start shooting things. Our performance stays pretty solid and we can keep shooting things and do what we need to do. And our CPU and GPU now stay at level 2 rather than jumping up to 4. So you basically half your GPU and CPU like times. So it's really useful to do some of those settings afterwards. So let's quit out and we can go from there. So this has been a bit of a long video, but hopefully all of this information helps you get your projects onto the headset, helps with some errors and along that part. But thank you so much to Patreons again. You will get access to the project file for this. I'll put it up as Quest settings. So hopefully you should be able to download those and give them a try on your own headset or Unreal and then kind of use that as a template to go from. So until next time, stay safe and I'll see you then.